Hello, welcome to our presentation for section 10, group 7. So we're going to present about digital video broadcasting. Uh, so the so the members are my name is Yusuf Mamdouh, and then we'll start Mustafa Mahmoud, and then we'll end Omar Mohsen. So first we're going to talk about the contents of this presentation. We're going to explain about the concept, the history and the advancement, and then we will conclude. So in first, what is digital video broadcasting? Digital video broadcasting is a set standards that define digital broadcasting using existing satellite, cable and terrestrial infrastructure. It was first introduced in 1990 by Europeans. DVP standards are maintained by the DVP project, an international industry of consortium, and are published by a joint technical committee (GTC) of the European Telecommunication Standard Institute (ETSI), European Committee for Electrochemical Standardization (CENELEC), and European Broadcasting Union (EPU). So today, the DVP project consists of over 220 organizations in more than 29 countries worldwide. However, Advanced Television System Committee (ATSC) standard is the digital broadcasting standard used in the US. So how it works? Digital video content is encoded using discrete cosine transform based video coding standards such as the H.226x and MPEG format. Digital audio content is encoded using modified discrete cosine transform MDCT based audio coding standards such as advanced audio coding AAC, Dolby Digital AC3 and MP3. DVP systems distributes data using different approaches like DVB-T, terrestrial DVB-T2, DVB-S using satellite, DVB-S2 or DVB-S2X, and DVB-C, which using cable, DVB-C2 also, DVB-H handheld, and DVB-NGH, DVB-T2 Lite, and DVB-SH, which is also satellite.
Hello, my name is Mustafa Mahmoud, and today I'll be talking about the T2 system specifications. So, for those of you who don't know, T2 really offers flexibility in modes so that the consumer can choose whatever they see suitable to find for themselves. So, first we'll start by the channel bandwidth that the T2 offers. It's 1.7, 5, 6, 7, 8, and 10 megahertz. Next, we'll talk about the guard intervals. What is guard interval? Guard interval is a technique used to ensure that the transmission signals, that the transmissions do not overlap, therefore causing noise. So we see in the presentation that we have multiple modes for guard intervals: 1 over 8, 1 over 32, 1 over 16, 1 over 128, and even more. So how do we choose between these guard intervals? Or how do we know which one is better for us? So for longer periods or longer guard periods, there will be less noise, but the channel efficiency will reduce. So for example, in the 1 over 32 case, it gives the lowest protection or the lowest protection against noise, but higher data rate transmission. And contradictory to this, the 1 over 4, it results in the best protection or the lowest noise, but lower data rate transmission. So next we'll be talking about the OFDM modulation modes. OFDM modulation is a method that is right before that method of modulation in which the signal or the the modulating signal is split into multiple data streams or multiple frequencies to reduce interference or crosstalk. So in here we have multiple OFDM modes: 1K, 2K, 4K, 16K, and 32K. Next is the FEC rates or control error rates. FEC is used by the coders or the programmers to ensure that there are no noise, just like the guard interval, but it's a different technique. In FEC, the programmer or the sender uses redundant codes or redundant signals so that the consumer can notice the errors. So next we will talk about the workflow or how the T2 works. First of all, we start by input preprocessing and input processing using the physical layer pipes. In T2, physical layer pipes offer way more options than the previous T version. It offers encapsulation, mode adaptation, and stream adaptation. The next step is the bit interleave coding and modulation. It's the step where noise is reduced. So this step's purpose is just before modulation. It is used to provide robustness against error propagation. Next step is the frame building, or this is the step that is just before the signal being sent. The transmitted stream is organized in super frames, which are composed by T2 frames and future extension frame parts. The next is OFDM. We already talked about it in the system specifications. OFDM is a method of digital signal modulation in which a signal data stream is split across several frequencies to ensure that no interfere or minimal interference on crosstalk. This is the last step of the T2 workflow, and after that the signal is sent, and that's it for me. Thank you for listening.
And now we are going to compare between the DVB-T2 versus DVB-T. As you can see in the presentation, we are going to compare between the most important characteristics, like the modulation, the PLPS, the DFT size, the input interface, and modulation schemes. So for the modulation, both DVB-T and DVB-T2 has OFDM, while for the PLPS, DVB-T doesn't, but DVB-T2 does. For the DFT size, DVB-T has 2K and 8K, while DVB-T2 has 1K, 2K, 4K, 8K, 16K, and also 32K. For the input interface, DVB-T has single transport stream, while DVB-T2 has multiple transport stream. And lastly, the modulation schemes. QPSK for DVB-T, 16QAM and 64QAM. While for DVB-T2, it has QPSK also, 16QAM also, 64QAM, and 256QAM. Lastly, for the conclusion, we're going to mention the advantages and disadvantages. So for the advantages, it's much more flexible, robust, and efficient than any other DTT system. It also uses OFDM modulation and offers a wide range of different modes, making it very flexible standard. It also enables the possibility to build much larger SFNS than what is possible for other DTT systems. SFNS enables the possibility to use the scarce resource of spectrum more efficiently. And now for the disadvantages. Due to its flexibility, it becomes difficult to select the optimal configuration. Large SVN requires a long guard interval that significantly reduces the capacity. Large SFN limits the possibilities to provide regional services. And by that, we end our presentation. Thank you so much for tuning in.